Good evening, everyone. We had a thought, why don't we make something that tells people what they are really eating just by looking at it? So we have been working on a model which classifies different type of food in various categories. We achieved this model through deep learning and neural networks.
We are importing the libraries, then the helper functions which will be used later in the code. Then we are loading the data, the training and testing data for our model. Then we are visualizing the testing data to get familiar with it. These are all the classes on which we will be categorizing our food images. Then we are doing data augmentation on the training set, as it will help our model to learn more with the augmented images than the raw training images. Then we are viewing the augmented images. Then we are creating a base model for our training data to check the accuracy. Here we are fitting the model on the training data with 5 epochs. And as you can see, we have a pretty good accuracy of 84% for our 10% of training data. These are the loss curves. Then for model 2, we'll be tuning the model and unfreezing some layers so that we can get better accuracy with our training data. So here we are unfreezing the layers, and as you can see, the bottom 10 layers are unfrozen here. Then we'll recompile the data and fit it again to the 10% of training data. We will evaluate the new model and plot the loss curves. The loss curves are not that great, but the validation accuracy is increased to 86%, which is good. So we'll continue training our model for the 100% of our training data. Using the same weights and biases, we'll train and update those. After this, we'll evaluate our model on the test data, and we got an accuracy of 91%, which is pretty good for 10 classes of food images. They are the loss curves, and these are all the accuracies, validation accuracies for all three models we created. So with 100% and 100% data and tuning our model, we get great results. Now to predict the model, we'll choose some random images which our model has never seen before, which are downloaded from Google randomly. These are the images, and then we are predicting the images with the help of our model. So as you can see here, we have chicken wings which have a probability of 1, which means our model is classifying this image as chicken wings 100%. These are few images. Now in this image the probability decreases to 98%, because there are noise in this image like this, and 90% like there are noises which decreases the accuracy of the model. So this is the final model which we'll implement. Now this model can be used in classifying random images which you can take by a smartphone